So today, again, welcome to what is really our first context, really, or in-depth conversation into the Commercial Energy Code Compliance Pass webinar. Thank you for joining us. My name is Josh Harmon. I represent the Minnesota Energy Code Support Program, which is a program designed and intended to support, educate, and empower building officials like yourselves throughout the entire state of Minnesota to efficiently and effectively enforce the energy code and other energy efficiency provisions that come into play. So again, this course is kind of our program. We had a little kickoff 2 weeks ago. Our program is really focusing on education, resources, and ways we can help you in better understanding or better facilitating community understanding of the energy code. So this is going to be a class. We're going to kind of walk through the very basics of what are the compliance paths, what are the different variations, variables. I want to make sure that we start this off when do you know when the ASHRAE 9119 will be on the deal? No, so we do not work for the state, so I don't control anything with the state. We can check into that and get it, whether or not that's, maybe that'll be, we can put that, actually, let me put that down as a thing to do. What I'll do is we can add a link to our website. See, this is why we have these conversations. 21. So one of the conversations that I think is important that we understand is if we understand the why, right? That's one of those things that just fundamentally, whenever I do training, and I will apologize now if for some reason my brain jumps back into the IECC world. I just got done teaching a class on mechanical inspections, and I'm getting ready to teach a class on COMcheck here in a little bit. And so my brain's going back and forth with all the different things that we have going on. But when we understand the why we have codes, then we can better figure out the how, right? The in-field piece of what we do. And we understand that the codes exist. And I want to make sure, just housekeeping from the beginning. So this course has been approved for 1 hour of education credits for DLI. This is also approved for ICC and for AIA. So if there are members who are interested, you will get an email at the end with a copy of your certificate, and then we will ask you for your license number or your AIA credential number so that we can report those back. For the question of when they get updated, that's a good question. I will figure that out and maybe send an email back out with that confirmation. And as far as if you have questions, put them in the chat, put them in the Q&A, or if you have a question you want to actually dialogue. It's way more fun when we can talk. Just raise your hand and maybe we can have some conversation that way. But when we think about why we have building codes exist to provide that basic uniform standard for construction, right? What are the expectations when we build a building to make sure that it's not only structurally safe, but that it also considers things like light, ventilation, sanitation, energy conservation, and really what are the considerations we have as we protect the public as they access commercial buildings. And so when we think about that in that context, the energy code, the energy provisions of the code are designed to further allow for that design to control or to encourage the efficient use and conservation of energy through concepts and designs that regulate what it says here: heat loss control, illumination, and climate. The name of the game in all of the building process, right, is control. If we think about it in the very basics, we want to control the flow of load through a design, right? If we're talking about building design at its very basic core, we're trying to control the location of material control and separate the exterior environment from the interior environment. We want to control how much how load transfers through a building structures, through the structural system. So we referred back to the building codes and through the building science that develops building codes to provide us those guidances on how much weight can a 2x4 hold, how much weight can certain types of steel hold, you know, when do we use certain types of classes of different materials. We do that same thing in the energy code. We start to identify, we want to control heat loss. Now, I had this conversation more than once this week in reference to different designs. We build tight, the question is, we build buildings so tight then we have to poke holes in them and ventilate them. Well, the reality is that while that may sound yet correct, and it is correct in a lot of ways, we're also able to control that air. It's better to control the air transfer than to allow air transfer unabated, right? Uncontrolled. And so by controlling it, we can make sure that it's done at the right times, the right capacities, the right quality of air gets into a building. And so again, that's where the code is really starting to go. Is how do we control what we use, and not necessarily with this mindset of how is it going to be effectively used in a building's design, right? And because we understand that buildings last or exist for more than just a 1 week period, they exist for their entire life span, and then a lot of those we want to make sure how do they use that energy over the course of its useful life. When we think about the scope of the conversation and it relates to the energy code, the commercial energy code, we're looking at standards for new buildings, new sections, new additions, so that we understand where these come into play in the context of our general construction. We also understand that they do not apply to those single family and two family dwellings, right? And the multifamily units that are 3 stories or less above grade. So those are situations when we're talking about that, when we'll refer back to maybe the residential code. But from a commercial perspective, we're looking at it for those obvious new additions and expansions, alterations to existing buildings, right? So again, when we think about that why, we're really thinking about the flexibility of how. Anytime that you hear somebody say, tell me the one way to do, tell me what to do and I'll do it. They're usually just being cavalier in their conversation. They don't want you to tell them how to do it. They want to give you the options they want to build with, and then how does that fit within the code? Is usually the conversation, at least I've had as a building official over the last 20 plus years. But when we think about the energy code, the commercial energy code, commercial energy code is really in a lot of ways an adoption of or tightly reflects the requirements of the ASHRAE 90.1 standard, right? That's one of the things we keep talking about. Now, I looked again today, and it's still not out as far as the reprint. Like I said, we'll put a link on our website just to make sure you have access and know where to go to get it. But again, that code is designed to break out the different components into 11 different sections and a bunch of different appendices, all of which were not adopted by the state as far as the appendices. And what we're really looking for are the technical standards behind different components within the building design, right? So when we start to move into what the state adopted appendices A, C, and G, which A is going to be the R value determinations, the methodology for building trade-offs, and then the performance rating standards. So when we really boil it all down, so how do these compare to, how do we simplify what our compliance paths? Because I know that's one of those conversations I have all the time and hear a lot from people, is how do I simplify? How do I explain this to someone? Well, it comes down to three basic alternatives. We have prescriptive compliance, we have energy cost budget compliance, and then we have performance rating of our buildings in the context of the ASHRAE standard and the Minnesota Commercial Code. Now, one of the things I think it's important for us to think when we track a project, and we're going to do this throughout the class today, we're going to track a project through section number 4 and identify first its compliance path. And with all these items, we see there's the evaluation of not only the construction itself, but also the conditioning, the space conditioning components. And then I think it's important to remind ourselves that in mixed occupancies, we're looking at not only how does it affect that we're treating the commercial and the residential separate, right? And so we're not going to go through all of section 4 because again, it's mostly administrative, and I'm not going to waste your time. And this is a 1-hour webinar. It's not. We could take hours to separate and drive into each one of these sections. But in all reality, new buildings are identified in section 4.2.1.1 to comply with one of the 3 options, right? They can comply with the prescriptive elements identified in sections 5, 6, 7, 8, 9, 10, or they can comply with section 11, which is going to be the energy costs or the normative appendix G, the performance rating system. If we're to take a look at some of those, again, we get into what are the compliance documentation that we're expected to find? What are different testing and verification expectations and requirements? But again, we'll take some of those in stride. As an exception, we recognize that historical buildings have different understanding, and that we're trying to not reduce the historic nature of it. Again, we'll have classes where we talk about the impacts of residential or the impacts of energy conservation on historic and existing structures, because that's a very fine conversation when we start to talk about how do you maintain historic character and make modifications. I've done a couple projects like that. They're not fun, but they are interesting. Let's just put it that way, from a building perspective, from a building and department perspective. Again, and when we talk about changing of occupancy or use, especially when we're thinking, with a multi-family, a multi-tenant building, we're not going to require every piece of equipment to be modified from multiple and differing environments. And so there's a lot of times where we're going to be looking at what is really a change or conceptually to a condition, not necessarily does it go from a nail salon and then or a retail store and then a different retail store comes in, right? We're not looking at it from that kind of occupancy change. We're looking at it in the context of, is this conditioned space, is this non-heated space or semi-heated space? So we'll talk about that a little bit more. Now remember, in the content, or to the extent that it helps explain the layout and organization of the 24 standard, sections 5 through 10 are going to have a uniform number system for their subsections that identify its general use. The number systems go from 1 as more of that general description of a particular section, including its scope and maybe some general requirements of the section. Item or anything that has that 0.2 in the second column is going to be for the compliance path recognition, to describe any process that may be different or unique about its compliance path. 3 is going to be simple buildings. 4.4 is going to be mandatory provisions. 5 is going to be our prescriptive requirements. 6 is going to be our alternative compliance path. That's going to be for things, maybe where we talked about, trade-offs between the elements of the building envelope with the lighting sections, or space-by-space method comparisons for power lighting allowances. 7 is going to be our submittals, and 8 is going to be our product information. So again, when you think about it in the context of the code, you're really thinking more, the first number is going to be our system, our second number is going to be our context, and then beyond that, we'll get into some, then it breaks down into our traditional numbering systems. The code identifies for us some expectations on what is expected to be provided to us in a plan review situation. And so with that, one of those key components I think is important out of the 18 specified items is going to be the compliance path, because the compliance path is one of those things that really drives a lot of the decisions as far as how far does the plan review go, what things am I looking for, or how flexible can the design be in inspections. And so when we think about the compliance paths, again, we're going back into that new building context. We're looking at it in those 3 different paths of prescriptive, energy, cost, and performance. We're going to break them down by their different building components, and we're really going to focus, I think, more so on this on the prescriptive path right now, because again, that's going to be the more regularly seen, and it's a good starting point to kind of basically understand the concept of what is it that we're looking for. Again, I know a lot of communities a lot of different projects, at least in my experience, have used the prescriptive path, and they've used some of the different methodologies identified as far as identifying, whether we're following just a R value factor and all that kind of thing. And so we'll talk a little bit about that. Is there a class that helps? The question in the chat is there a class that helps us better understand COMcheck versus just looking at the last line that says? So yes, we will have a class we have classes that will do a deep dive into REScheck and COMcheck, really identifying how they're developed, and then there's also a separate class that we'll do on reading compliance path documentation. So absolutely, we'll have classes to that. Just keep an eye out for our website to keep an eye on what kind of classes are coming up. If there are specific things that you think are important, please feel free to go on our website, send us an email, and let us know that there are certain classes that would be helpful to you, and so that we can make sure that we provide them. So again, we're going to be going running through just so we can get through these different sections. When we can think about the building envelope, some of the first things you have to identify are going to be obviously going to be our climate zone and our condition type, our condition space type, right? So we're going to have climate zone 6 and 7, and then we're going to identify for it within that, are we going to have a non-residential condition space, a residential condition space, or a semi-heated space? Now the code allows us to also identify non-heated spaces, but that's at the discretion of the building official. And so when we take that, when we really start to go into that, we understand that the compliance for the compliance requirements for the building envelope, when we talk about it in the prescriptive, is really for all. There are sections that are going to comply with all of the different compliance paths. Now remember, that's why we said we're breaking it down by different expectations. And so we're allowing within that building thermal envelope, or within that building envelope, we're recognizing that there's more than one way to skin a cat, right? There's going to be the traditional, I guess we'd call it the traditional compliance path, and there's going to be the trade-off compliance path. You know, a lot of times, again, we talk to people and you talk to builders and they tell you, just tell me what to do. This is what I'm going to do. And in all reality, they don't like the options that we give them in the code. And so that's where we get to this conversation between what is really the prescriptive R value approach, the U factor approach, and the total UA approach to prescriptive compliance for the building envelope. Within those mandatory provisions, we're going to identify the role of insulation. We understand that insulation is a key component. And then we're also going to look at fenestrations, doors, air leakage as different considerations, because we understand that the envelope is what's separating our conditioned space from our unconditioned spaces, from the exterior impacts of the environment versus the interior controls that we're going to have. Remember, we're trying to control what we do within the building so that we as the building operators have that ability to restrict, control, and manage what goes on in that building. And ultimately, that's where building owners, and whether we're talking residential or commercial, are really looking for that level of control so they can control when the lights are on, when the different equipment are running, so that, again, we're thinking about costs for those maintenance and operations. One of the things that, again, that we want to remind ourselves of, and I probably should have said it earlier, is a lot of what is important in understanding compliance is less about code and more about the quality of installation, right? It needs everything in the codes reinforce this, whether we look at the building code or the energy code. Everything needs to be installed in compliance with the manufacturer's installation instructions. You could install the best thermal envelope you've ever seen with the thickest walls and the greatest amount of insulation. But if you don't install it properly, then again, it really is all for naught. And so it really becomes a question of just installation expectations versus a lot of times the material that we're identifying, because the material allows for that flexibility. When we're following that building envelope compliance path, we're looking at our tables, right? We're going back to those tables that reference climate zone 7 and 6. We're looking at the different elements that exist within those tables, whether we're looking at roofs, walls, floors, or operable fenestrations and doors. And we're applying these values to the material we see provided, right? This is the one that takes the longest, at least in my experience, with plan review, right? I'm going in and I'm identifying, you're going to follow the prescriptive process. We're going to follow the building envelope compliance path. We're going to just look specifically at every wall design, and is that going to have the adequate amount of either insulation in the context of either U factors or R values. So this is the one that takes forever, and we'll do some more deep dive into this a little bit as we go. The secondary option is that building trade-off compliance path. That's where you're going to get a variety of different reporting softwares that are going to simulate through the computer system, through the software system, simulate how those materials are going to operate as an assembly, right? They're going to do some calculations on a more holistic approach to the building versus individual components. So you're going to get it's a really fun process. And again, like I said, I just finished a class on, or just taught a class on REScheck, teaching one on COMcheck here in about an hour or so. And again, it's a great conversation, and it's really, to me as a building inspector, it was great to understand. Obviously, I'm not going to go in and build one to use it regularly, but it is one of those things. And again, I think it'll be a good class for us when we have it, to really understand how these softwares operate and what it is that, as a building official, I'm supposed to be looking at. Not like the question was, I'm not just going to look for that green bar that says it's 3% better than expected and move on. There are certain things that we need to verify, and we might get a chance to talk about some of that today. But when we're talking about the building thermal envelope, we're talking about those concepts of, that the traditional, what is in the wall, right? That's when we always go back to our values, we go back to U factors. And a lot of times we're thinking that that's actually resisting that it works, that insulation in and of itself is all that we need to think about. Well, insulation resists the transfer of heat, right? But it doesn't resist the transfer of air. And air is really what's drawing. We've had some fun weather here lately. I don't know if any of you got the chance to go out and see the aurora lights, the northern lights over the last weekend. But, if we truly understand, air movement is actually going to be is really the key, is really a hat and glove kind of relationship with what we're talking about. In those contexts, we're going to see that regardless of whether or not a building has great thermal insulation, if the air barrier is not installed properly, then we're going to get a level of air leakage. And that air leakage is going to draw or pressure, that pressure differential is going to cause that air to transfer through. Insulation, for the most part, is designed to slow that, to impede it, not to stop it completely. And so it's that transfer of air, of thermally charged air through that system, that causes a lot of times that air to be deposited in the actual insulation, and then it resists the further transmittance of heat through it. The concept of thermal diffusion, the concepts of thermal transmittance through a material is really not something that's new. It came out originally, was recognized. I mean, if we go back and think about it, if we go back to 200, 300, 400, 500 years ago, we were building buildings that used moss and leaves and different materials to insulate a building. We're just using different technology, different materials today. We have ASTM standards on how we actually calculate thermal resistance values, how we calculate those U factors and R values. And in all reality, the U factor as a measure for thermal resistance was created back in 1701. Isaac Newton wrote an article, documenting the concept of calculating thermal resistance. We use obviously a little bit more advanced technology now, where we place materials inside the oven that you see on the screen. We monitor the temperature, the relative temperatures on both sides of that material as heat transfers through it. We calculate over time how many BTUs of heat go through a given square footage of material over an identified period of time. That's how we get an R value or a U factor. Now remember, U factors came first. They're now celebrating 325 years of existence. The R value actually came after, as we came back out of World War II. Insulation manufacturers became more, with technology, we obviously were getting a little bit more advanced, and so insulation manufacturers wanted a value that would get better as things perform better in resisting the transfer of heat. And so in 1945, they commissioned a Penn State University professor to create the mathematical calculation that we now know as the R value. Literally, I'd love to know, I can't find, I have researched how much this Professor Schumann was paid. His name's Everett Schumann. How much he was paid? What was the fee to take the mathematical value of the U value, which again has been around for years, and divide it by 1? That's all an R value is. It's the complete inverse of the U factor. The U factor, again, is going to be that collection of that click the button. that area weighted calculation of thermal resistance given all the materials within a given assembly, right? We normally assign an R value to a specific item. We assign a U factor to the entire assembly, right? Because then we're calculating how much, what are the different respective values of all the different components within a wall design, right? So we're looking at sheathing, we're looking at exterior wall coverings, we're looking at potential continuous insulation, cavity insulation, drywall. All of those elements have a thermal resistance capacity. It may be very low in certain instances, but we're going to calculate all of those, weight them across the wall assembly, do some math, which we're not going to get into, and then that gives us our U value, right? The building trade-off method that we saw in the compliance path does that math on the grander scale of the wall, right? So if we're doing that, and again, maybe we should have thrown in some more pictures of the COMcheck or REScheck. But what you're doing is you're going to put in a value for a wall's square footage of wall area. You're going to tell it the framing factor, right? How are we doing 16 on center? Are we doing 24 on center? What is the different values of the cavity versus continuous insulation? It does all the math and spits out a very quick answer. Deducting, you're going to insert values for windows and fenestrations like we talked about in that wall envelope. But all those calculations go into it, and that's how we get the U factor. Now, again, we recognize and need to recognize that all the different material that we utilize in a wall envelope design is different and unique. Very rarely do we find materials that are the same from one classification to another. If we're talking about whether we're talking about a blown-in insulation versus a poly-iso, rigid continuous insulation, maybe some extruded polystyrene or expanded polystyrene, fiberglass batt insulation, spray foam, open cell, closed cell. We'll have a conversation at one point here in the future talking about insulation options and wall design alternatives, because there are a huge list of different insulating materials, and each one of them comes with their own respective R values. And so we may see where you may use a polyiso at about 7 R per inch versus I was at Lowe's the other day, and a core of a section of XPS, expanded extruded polystyrene, was going about 5 R per inch. So you may use that in different situations, and they also have different capacities. And so again, we'll have a greater, deeper conversation about that. Now, again, remember, if anybody has questions, please let me know. I don't want to go too fast or take up too much time with my own conversation. But what we're going to do is, in the process of this plan approval, we're going to document where these different components are going to be located. What are the different spacing or space conditioning categories? So if we have a semi-heated space versus a conditioned space, then we're going to have those identified so we know where those thermal separations go. It is critical to understand in a plan review where the thermal envelope goes so that we can clearly, during our inspections, identify the expectations we should be looking for. And we're also going to have, as part of that conversation, because we know that's where windows are going to be installed, we're also going to look at maybe labeling of our daylight areas. So again, there's a lot that goes into the building thermal envelope considerations for a project when we follow that prescriptive process. We're not going to go over the different requirements for, except to say they exist. As far as documentation, managing different records, inspection protocols and inspection. Again, that's a lot of that comes into, we'll see that consistently across all the different concepts that we see within our design components. But we're moving on to the HVAC system. Again, we're going to follow that same kind of concept, right? We're going to identify what is our compliance path. Are we following a simplified approach, or are we going to look at more of the prescriptive or energy cost or performance paths, right? What that's going to drive us into what is the evaluated elements that we're going to identify and how we're going to verify those things. We're going to look at, again, mandatory provisions. There is like I said, a simplified approach, which is going to be, again, looking at buildings based on the different qualifications, criteria, The ones that I think again, we're looking at certain systems that are going to be very simple, right? We're looking for buildings that have less than 25,000 square feet, that they represent most buildings that we think about, if you look at some of the different studies, they're showing about 80% of new construction is going to fit inside this. And so again, we can have a little bit more simplified review of that expectations. Many of the things that we see don't apply to the simplified system. So rather than going through that long process, we can identify right up front, is the HVAC system going to follow the simplified building approach, where we're having a single zone, we're going to have one system, or we're going to have a multi-system that's going to go maybe in a school or a hospital or something like that. So again, there's that approach. The thing that we get into a lot is we understand that the calculations for the airflow and mechanical design are held more in the mechanical section of the code. The energy efficiency sections of the code are really driven towards how does that perform and what are the minimum expectations for energy efficiency given a particular size of equipment. So you'll be going through tables, identifying, and that's where it's always fun, right? Everybody loves going through the tables and identifying what is the type of equipment, what is its rating, what is its output, and what is its efficiency. We will have some conversations more. This is more of that overall overarching 10,000 foot review of the compliance pass, but we will have some conversations. I know we're looking to have one with we're tentatively scheduling for sometime in June to meet with the Minnesota Association of Plumbing and Mechanical officials to do a class on mechanical design considerations for the energy code compliance. So again, those are going to be opportunities that we're going to have to dive deeper into those tables and how to accurately read them. And again, we'll have classes on reading and reports. But again, we understand that there's going to be materials that are going to be listed and in that, and then there's also going to be some expectations for non-listed equipment. And then also providing us what are those basic calculations, when we're talking about how do those calculations get determined, right? So again, this is where we're going to find some of those provisions. We're not going to go running through all of them. If we were to really take the time to go through this, we could be here for hours. But I think some of the important things to think about when we talk about mandatory provisions for HVAC components that are following the energy code, a lot of it focuses on controls. Again, it's all about controls. It's all about knowing what our system is operating, how it's operating, and making sure that we can control and how those systems use energy in their operation. So again, that's where you're going to see things like our setbacks, our zone isolation. I know of many projects that I'm sure you guys all have examples of as well, where these considerations were not identified in the initial operation, the initial construction. Moving forward into new versions of the code, they become mandatory in new additions and new sections of the building. And I always get the phone call. Maybe you get the phone call. I get the phone call from an owner saying, "Hey, what are we going to do to make this happen to the rest of our building?" Because we realize how much money we're saving, and we're spending. Again, I've got a project where they put in a 40,000 square foot addition on a building, and that was already 25,000 square feet. And so they spent less energy on that 40 than they did on the 25, and they were like, "We want to make this change." So these types of controls are really where it comes down to. It wasn't relining or replacing all the wall envelope. It was modifications like this that were allowing them to save money and to make their building more comfortable throughout the process. Other mandatory provisions are obviously going to be in the installation and construction. And that's going to include, again, how are the systems where are they going to be located? Are they inside heated spaces? Are they outside heated spaces or conditioned spaces? Are they we're looking at air leakage, air sealing. We're looking at the duct systems. We're looking at all these different elements that help drive how effective is this system going to be at its purpose of heating and dealing with heat transfer or conditioned space. Remember, when we insulate ducts, it's really less to change the temperature of the air as much as it is to maintain the temperature of the duct itself in relation to the air that travels through it. That's why you're not seeing huge values. That's why you're not seeing an R30 wrapping a duct. You're seeing an R6 or an R8, because really what we're looking at is maintaining the temperature of this heated duct more so than tempering or controlling through the duct itself the air that's already potentially thermally charged or cooled. There are some prescriptive requirements for economizers and when they need to be installed. What are the expectations and different controls and we'll get more into that when we talk about considerations for mechanical installations. So moving on to service water heating systems, we know again we follow that same expectation as far as what are the, when we look at it from the compliance path, we're looking at it from a prescriptive compliance process. Again, we're going to review those sections. Again, if we go to section 2, it's going to remind us again if we're going to follow all the paths versus just the prescriptive path. What are those different expectations? What are those different subsections we should be referring to? To me, a lot of it, and I'm going to say this and be mean, is repetitive because of that. We keep reminding ourselves over and over that these are expectations for everybody. These are the expectations for the prescriptive path. And so it's one of those things that, again, we need to, when we start thinking about it in that context, we can really kind of see that anything that's in that 0.4 is going to be mandatory. Anything in the 0.5 is going to be prescriptive when it comes to a particular section. So mandatory provisions, again, we're going to make sure that we understand the load calculations, we understand heat traps and different controls. Again, when we think about it, we see all the time a design come in and it's like, where did we come up with the load calculation that drove us to the decision of installing a particular size equipment? That's information that we as building officials need to be provided and review to make sure that we're actually all on the same page. I've had a couple different projects, and again, I know you guys probably maybe have as well, where you evaluate a project, you look at it, and the square footage is completely off. It says 5,000 square foot, it's a 60,000 square foot building. The climate zone is it's using Denver as the location, not a Duluth, right? So there may be some equivalency, but there may not be the equivalency that we're expecting, especially when we evaluate things like elevation and different things like that. So making sure that we have that the information we're reviewing is accurate to and representative of the community is really one of those key components that we have to identify when we look at load calculations, both in the prescriptive and in the other two compliance paths. When we look at it from a truly prescriptive path, we're making sure that the equipment is both efficient, and we have different ratings at the table to tell us, what are those minimum efficiency expectations, as well as certain considerations for maybe concepts like water heat recovery systems. What are these systems providing? What are we trying to accomplish? What are those controls? What are those different efficiencies? A lot of times, especially and just because that was in my brain, the drain water heat recovery system is really going to be one of those systems that says, or one of those code provisions that says, if you have it installed, it should operate this way. A lot of times, one of the things that we get confused in is when we say prescriptive, people think we have to install everything in the list. And a lot of times it's important that we read those sections. It doesn't say everything has to be installed in that section. It says that if it's installed, it follows this expectation. So again, clarifying some of those things are really going to be important when we think about the importance of compliance path identification. Power distribution is one of those things that a lot of people forget, don't think about, or don't fully consider. We take a lot of times, it's going to be one of those, it's easy, we throw it in there and it's done from that perspective. We have different, areas within a building that maybe, especially with certain types of commercial designs, that may have different power usage and needs. And so it's important that we really allow for that designer to have that flexibility, have that design reflective of the use and operation of that building. When we talk about, again, the next one, talk about some of those mandatory provisions. We're talking about, automatic receptacle control. Now, I will tell you the one receptacle that I think is the most important not to control or not to shut off is the coffee pot. The coffee pot should be on a 100% constantly engaged receptacle. And when you look at some of the code provisions, when it talks about, how are we looking at HVAC systems, some of these systems, and where we place those automatic receptacles, those are considerations that actually are becoming more and more important and start to get identified. It was kind of funny at first, but the more projects I see, the more I see kitchen areas that are identified. And so this is not going to have, we're putting the coffee pot next to Keurig next to the refrigerator so that we don't have those disconnects. So really that's more, again, one of those sections where it's maybe the exceptions that we're looking for versus the rule. And again, with the compliance paths, again, we're looking for how do these buildings operate. We recognize the importance of IT and computer rooms in their alternative compliance requirements. But really what we're looking at is how does the building operate? Especially simple would stop meeting 24/7. I don't know, Jesse. I'm saying I drink coffee all day long. That's my only problem with the automatic control. So I drink coffee till like 9 o'clock at night and I start at 6 in the morning. So maybe depending on your coffee pot, we may have to talk about that. Maybe it's an occupancy sensor driven and not automatic time based. That'd be a good conversation to have. I appreciate you interjecting too. Trust me, I love it. It's very helpful to know people are still there. When we talk about lighting in that context, we're also talking about how do those lighting systems work. That's a lot of times when we get back into that simplified versus building area versus space by space method, right? Where how are we identifying the lighting requirements of a building? Again, I have a complex here in my community that operates very irregularly, and so solar panel input for my coffee pot not going to happen, Dean. I'm telling you that right now, right? And so when you think about it in the context of different of the lighting requirements, I've got a building that, again, the one that I was just talking about, 60,000 square feet. Monday through Thursday, they operate at about 12 to 15 employees. They go through the building constantly. But on Friday, there's only 2 people in the entire building, right? And so managing their lighting control, considering how interior lighting is done in that type of an occupancy can really demonstrate why it's so important to have occupancy controls. Why it's to really think about how do we calculate, what do we allow as far as wattage and how do we use those spaces. So sometimes it's easy to throw I'm just going to do a retail space, I'm going to do a education space, and then in reality it would be a lot better to show that as space by space given a different design. So we'll talk about lighting in another class, but I understand that is one of those considerations in prescriptive compliance. And I know many fire marshals that I've given a cup of coffee to, Mark. I'm just saying. And so when a digression, because I don't care. I think it's a good story. So when I worked for the court system, I was an inspector for the building for our court, and my office was well known as the place. If you wanted a cup of coffee, you would show up. And so there'd be days I'd go in there and there'd be a couple detectives in my office, and I always thought, "Am I in trouble?" Oh no, we just came for the coffee. So I've had fire marshal detectives. They love the coffee pot. Now it's become a thing, but no solar panels for it. Anyhow, digression. Again, so we're calculating, again, what are the different interior lighting power allowances? How are those different for maybe the power and operations as a whole? And again, separating them out by those different calculation methods. Using those different tables. So the question is, if a company is just changing out lighting to be more efficient, do they need to submit a COMcheck report? So in my jurisdiction, no, because again, that's going to be, if they're just changing the fixtures, they're not replacing they're not doing any changes to the panel, anything like that. Generally not. Now, it may be useful for them to do a COMcheck so that they could calculate what that may do for them. And that's one of those conversations that I think most of us on here are going to be building officials, but I think that's that conversation that changes over. ASHRAE section 402, Steve. So when we start talking about, when we talk about where energy efficiency becomes a tool, that's one of those conversations that we have with design professionals all the time. Use these resources that exist so that you can demonstrate to a client or potential savings, right? Because that's going to be a conversation that would be helpful. And it again reinforces that not everything is really the code making me do it. It's because it makes sense in certain applications to just do it. So again, looking. We'll go back to those charts. We'll identify basically an interior space that we're utilizing. What is that potential allowance is calculated? What are those specific controls identified? So again, that's where we start to get into that a little bit more. And again, those are elements that we should be seeing on our plans for new construction, so that we identify what is going on both interior and exterior. Now, again, exterior lighting is one of those fun things. Because I see it more and more in the context of facade lighting, but then also a holiday or decorative lighting. A lot of facade lighting, at least a lot of them around me are becoming more technical, right? And so they're using, and I think that's an important conversation to have with them about, as a community as to what types of lighting we're using. And that's again a reinforcement of some of those concepts. We did a study, we did a cost benefit analysis on Christmas holiday lighting displays, and the cost difference for some of those systems when they were using older bulbs versus newer bulbs, the LED versus incandescent, the cost differences were huge. A normal 10 strings of lights is a difference. So we just did, even if in a residential application, 10 strings of LED lights will get you about $9 a month, whereas an LED $2 a month, and the incandescent was $11 a month. So it was a $9 difference just in simple math and simple lighting systems with just 10 rows of LEDs. So again, conversations like that when it comes to exterior lighting, we have organizations that love their trees and love to show them off, and again, so they wrap their lights or have lighting systems out there. So again, part of that conversation is going to be about controls. It's going to be about, are we having daylight sensitive controls? Are we having automatic controls? Are we using timer controls? Because if the building shut off at 2 a.m., I shouldn't drive by some buildings and see all of their parking lights on. They should, and a lot of them are, and that's where the code starts to identify that those are things that we need to think about. And hopefully their coffee pots are off as well. So again, we'll be looking, there's all the different charts to tell us all about the different compliance paths. I included all these. Now again, at the end of class, I will be emailing you out your certificate as well as a copy of this, so that way you have them back for your reference. A lot of the things that maybe I've thrown in here, I don't really think we're going to review as much as we're just going to throw them in there so that you have them for your record. But again, there are a variety of different tables and tools to allow a project to identify the appropriate power lighting system. And then the code also identifies a variety of different other equipment as far as things that we consider like elevators, pumps, whole building energy monitoring systems, escalators, those kinds of things. And the code just says that if we're going to have those systems installed, we need to follow certain prescriptive requirements as far as, or expectations for their installation. Now, we've talked about the mandatory prescriptive requirements. Really quickly, we're going to jump into the energy code compliance. Remember, we're tracking this as if we're thinking about this in the context of a new building. And so moving that along, we're going to remember that when we look at the energy cost benefit analysis, we're doing everything in the building except for designs with no, this doesn't apply to examples or projects that have no mechanical system, because really what we're looking at is how does that building operate versus what are the structural components. If we were just looking at the building that has no mechanical system, we might as well we're just really looking at the building trade-off compliance path, right? We're looking at a COMcheck that just tells me this is the envelope and this is what it's doing. We really need, if we're going to do this evaluation, it's going to be on systems that have mechanical equipment, because we're going to be trading off certain components in order to, in relation to our, we're trading off components, right? We may have a more efficient mechanical system and a less efficient wall, but there's still going to be some level of expectation, right? As far as what are the limitations of that envelope. Now, we cannot take it to a level or degree to where we're going to say, okay, we're going to put in just OSB and that's it. We're going to have the most efficient energy system. We're going to have some level as far as what are we expecting that building to look like. And we want the entire package together. We're not going to have some kind of and a lot of times we don't want some phased permit, right? Where we're going to have, design it this way, and then we're going to throw in all the pieces later. With the cost benefit analysis, the energy cost budget, not benefit analysis, energy cost budget path, we're looking at, again, how much does it cost to operate that building as a whole? And so we need to have all those details up front. Now, this is where you're going to have a report at the beginning and a report at the end to confirm that the materials, that everything that was proposed and installed all match together, and that the building still performs at its required element. Now, this does allow for some consideration for on-site renewable generation, but that's limited to that 5% of the calculated budget, because we at least in the context of what's been up to at this point in this version of the code, we recognize that renewable energies are not fixed permanent fixtures in many situations, and so it would be if we were to say we're going to install solar or some kind of renewable that was going to wash out all of our energy, and then 2 years later a new owner comes in and removes it all, then it really did nothing to benefit the long-time useful life of that building. So again, the energy cost budget path limits it to that 5%. It gives us some different design expectations, how we identify what is purchase power, and how are we doing that mathematical calculation. A lot of times this is run through software that's going to generate some type of report. It's going to give us a annual cost calculation that we're going to compare from our reference design from our reference standard to our proposed design. That's going to come up with some mathematical calculation that says, before the introduction of on-site renewables, this is what we were expecting to get as the performance-based annual energy cost. It's a very small project versus the design project. In this compliance path, we're looking for how do these two compare? Is it equal to or less than? And some alternatives also allow for maybe a percentage of compliance. So again, it's going to be really a reflection of what compliance paths we're identifying. What are those expectations? And so in this situation, even though it's $8 difference, it would be compliant under that code. There are a variety of different, I think we've talked about this before when we talked about resources last week or 2 weeks ago. There are a variety of different resources and out there that people can utilize. Some that I've seen and are included on this list. By no means is this exhaustive. Is this a recommendation for any of these? But these are just great, these are resources where I've seen these paths, seen these software platforms used. Most of the software platforms that we see coming into the market, and I know DOE is working on one as well. The DOE COMcheck is more for the prescriptive side of it. They do some total building performance, but it's really kind of, not really their focus yet. They're looking for more of that just because they understand the value of it. But again, not to say that any one of these may be, and you may find a project that has more or different components. Moving into our third compliance option, because I know we don't have very much time left. We're looking at our performance rating index. That's going to be normative appendix G. And what we're then looking at is the context of how does the building perform. It's not necessarily all about money and the energy cost. It's about how does that building perform. Usually that's going to fall to some type of a rating authority like USGBC, GPCI. There are other organizations as well that provide different rating capacities. It tells us what a rating authority is as far as the definition. And so again, the performance path is going to be using Appendix G to identify methodologies for data analysis, for for energy calculations, for proposed designs. And so you're going to get, in the end, a report that's going to generate a proposed design that demonstrates compliance, as well as what is that final construction. Now, I will point out that one of the things that needs to be really considered, and maybe not by this group, but I think it's one of those conversations that we should have as building officials and building inspectors, is that the importance of the rating process is is really the fundamental part of this conversation, right? And talking with some raters, some energy program raters last couple weeks ago, if they go out on a site and they verify that, or they go and do an inspection as part of this project, because they're confirming the installation of the materials that are identified in the proposed design. If they don't get to provide that final that qualitative approval, right? And let's just be honest, if they go and do an inspection for insulation and the insulation is already covered up by drywall, then they are by protocol required to rate that as a grade 3 installation. Now there are 3 grades, 1, 2, and 3. 1 is perfect, 2 is a little bit bad, 3 is what was the point of doing it, right? And I'm being, you know, super simplistic there. We'll talk about insulation grading later. But if they don't see it, they have to rate it as a 3, which then affects how the cost calculation, how that energy modeling works with the system. And so in the end, it could potentially fail a project simply because they didn't get to see the installation of, you know, as it was designed. That's one of those things that builders sometimes don't know. And so they think they're fine. They're just going to move through and this rater's going to come and do their job. They'll be fine. Well, in the end, that rater has no, you know, is just going to do their inspection, mark it as a grade 3, submit the report. At the end, you're going to say you failed because you did not pass the value that you were supposed to. So again, that's just something that we should maybe, you know, be aware of. And in the context of maybe some of us do talk with our building contractors, that may be something, hey, if you're using that, make sure that they see everything when they fill out their reports. Again, on-site renewables are a part. You get the same kind of reports, a variety of different reports from a variety of different locations. So again, all of those are options. So again, our 3 different compliance paths are going to be our, you know, our prescriptive compliance paths, our energy cost budget, and our performance ratings, right? So we're looking at how does it meet the requirements, how does the operate as a whole, and what is as far as costs are concerned, and what is the performance rating. That's really it for this class. I mean, like I wanted to keep it very high level. I know we've got probably, let me see if there's any more questions. Are heat from lighting systems taken up in the code for energy transfer? So yes, it can be incorporated in a potential design. So if you were using, let's say you were using a heat lamp in a project, then that would be calculated in some of the manual J calculations, or some of those mechanical design calculations that get applied to how we redistribute or how we deal with the heat in the conditioning and air conditioning. Now I've got a project that we're working on now that has that kind of a problem where they only want to cool it, they never want to heat it. And so how do they deal with that? And how do we define semi-heated spaces? And that might be one of those calculations or conversations in that space to have. We can talk more about that, Dean, in maybe a future. I'll take some of these comments with us. Now, I know we got 2 minutes left, so if there's any more questions, please feel free to let me know. Put them on the chat, throw in the Q&A. As far as some upcoming training, remember we offer these webinars the 1st and 3rd Wednesday. There was some, Zoom is unique, right? Zoom did an update and threw some things around. So just to double check, we are always the 1st and 3rd Thursday at this time. And we'll be doing on the 6th, we'll be doing commercial design. More of a design consideration, and then we'll do commercial inspections, air barriers, insulation. We may throw in some alternatives. We may change this up as some of the conversation comes in. When you go to, remember, if you're interested, you're more than welcome to participate. We'd love to have you come to our first in-person free training up in Hermantown. This, again, we will be moving around. It will be a different training at each location, reflective of what that community wants to hear. But again, we'll be doing a different live in-person training somewhere in the state every month. So we'll be moving towards you over time. So you don't need to all drive up there, although you are more than welcome to if you're interested. We do have the code helpline. So if you do have questions that you want to have answers to, you can go on our website, minnesotaenergycodesupport.org/contact, fill out the helpline. Those are anonymous, and then we will be curating curating those comments as we get them and putting them into a frequently asked question section. Had trouble getting signing. Is there a better link that you can use? I will send that. I'll add that to the email that comes out, Dean. If anybody has any questions, they can always reach out to us. There's our emails. Again, if you have any questions, any concerns, when you leave the training today, you'll be asked to set a survey questions. Feel free to please answer those, and in there put in any potential comments or questions, any trainings that that you think would be helpful, any resources that would be helpful to you as we develop maybe some compliance guides, some submittal checklists, some plan review checklists, inspection checklists. We'll be doing a lot of those kinds of things as we move into the next couple of weeks, but we want to make sure that that's what you want, not what we think is a good idea. So again, technically our time has expired, but I'll stick on for a little bit while we maybe have some more conversation. Again, if you don't want to use the Q&A, you don't want to chat, send me an email. And again, if you ever have a question throughout the project or throughout a training and you want to talk, raise your hand and I'll unmute you. Again, this was very high level. It really was, and as we go through it, trust me, it's one of those things where you got to really deep dive into it. I know when we do our Hermantown class, we're going to do a little bit more deep dive into the compliance paths because we will have more time in that opportunity. So you guys have a great week. Be safe, and we will see you on the next time.